Our quest to discover the most distant galaxies in the universe has taken an exciting turn. The James Webb Space Telescope has identified 15 galaxies that appear to have existed before the Big Bang, sparking a new era in the search for the oldest cosmic structures. Since its launch, Webb has astounded us with groundbreaking, seemingly impossible discoveries, leaving the scientific community searching for new explanations. With this telescope, the mysteries of the universe never cease to amaze. A marvel of modern technology and a game-changer in natural science, the Webb telescope has revealed 15 breathtaking galaxies, so distant and ancient that they challenge everything we thought we knew about galaxy formation. Since mid-2022, reports have flooded in, describing galaxies so old that they defy conventional models of the early universe. The very foundations of the Big Bang theory are being questioned and refined. Scientists are grappling with these astonishing findings, unsure of what lies ahead. And yet, Webb's journey has only just begun. With just a single glimpse into the early cosmos, it has already rewritten history. As it continues to explore, we may soon witness even more mind-boggling phenomena, colossal black holes older than the universe itself and galaxies that defy the very laws of physics. How old is the universe, really? Have you always believed that our universe is 13.8 billion years old and originated from a massive explosion? While these theories have been widely accepted, doubts have always remained. Upon closer examination, recent discoveries reveal growing inconsistencies in the universe's expansion, miscalculations of distances, and ongoing revisions to its age. The James Webb Space Telescope is merely concluding a debate that has been ongoing for decades, driven by continuous advancements in technology. Although our understanding of the universe's age has seemingly become more precise over time, keen observers have noticed that scientists may be making more educated guesses than definitive conclusions. The estimated age of the universe has already been revised 3 times before settling on the current 13.8 billion years, but now, Webb's findings suggest that even this figure may be incorrect. A key aspect of the debate on the universe's true age and the distances of galaxies has always been the phenomenon of redshift. Redshift describes the stretching of light waves toward longer, redder wavelengths. Traditionally, the measured redshift values have been used to determine how fast a galaxy is moving away from us. The greater the redshift, the faster its movement and the farther its distance. This concept has long been a cornerstone of the expanding universe theory. But now, the concept of redshift itself is being challenged. It may have been misinterpreted from the very beginning. We still do not fully understand how dust, gas, and other interstellar matter affect light as it travels toward us, potentially altering its color in ways we may have misread. Swiss scientist Fritz Zwicky proposed a fascinating alternative perspective on redshift nearly a century ago. He suggested that as light moves through space, it experiences a slight loss of energy, or fatigue. In other words, redshift may not be caused by the universe's expansion but rather by light interacting with matter or radiation fields in space, gradually losing energy and shifting toward the red end of the spectrum. Simply put, this would mean that the source and the observer are not actually moving apart, which would upend the idea of cosmic expansion. What would be the implications of this? The answer leads to several intriguing possibilities. For one, it would suggest that space is not expanding from an initial point. This, in turn, would challenge the very foundation of the Big Bang theory, along with our current understanding of how the universe might eventually end. So far, we've explored theories like the Big Rip, where excessive expansion causes the universe to tear apart, the Big Freeze, where expansion eventually drains all energy, leading to a frozen, lifeless cosmos, and the Big Crunch, where the universe collapses in on itself, again due to expansion. But what if expansion doesn't exist? In that case, we might be living in an infinite universe, a bubble universe, or even a 12-dimensional reality, of which our current understanding only captures a small fraction. Physics, can we determine the true age of the universe? This leads to an exciting question: will we ever be able to determine the universe's true age or its actual size? Right now, we simply don't know. It's possible that new dimensions and discoveries will continue to unfold, keeping us from ever finding a definitive beginning or end. Consider this: 500 or 600 years ago, people believed the Earth was flat. Even astronomers once thought the Sun revolved around the Earth. Yet today, we peer an astonishing 13 billion light-years into a cosmos that constantly surprises us with new revelations. If you seek absolute answers, you may be disappointed. But if you embrace the unknown and the mysteries of the universe, discoveries like those from the James Webb Telescope will provide endless inspiration. In the summer of 2023, Canadian researcher Rendra Gupta proposed a theory suggesting that the universe could be at least 26.7 billion years old, if not older. His calculations incorporate recent discoveries, Zwicky's concept of tired light, and modifications to cosmic constants. This model has already been tested and found to be consistent. However, this does not mean Gupta has uncovered the absolute truth, only further observations will determine that. Imagine the James Webb Space Telescope continues to reveal even older galaxies and phenomena that defy explanation. We might soon peer back 14 billion years and see a universe that appears just as it does today. If that happens, it would suggest that the Big Bang occurred much earlier, or perhaps never happened at all. One thing is certain, every new discovery based on real observations brings us closer to understanding the universe. For nearly a century, observations of black holes and galaxy dynamics have largely reinforced classical physics. But now, things are changing, and we are entering a period of scientific upheaval. Physics appears to be at an impasse on multiple fronts, and this breakthrough could provide the key to moving forward. Microcosm and macrocosm, something doesn't add up. Few realize that physics is now encountering fundamental limitations across nearly all scales. In astrophysics, these ancient galaxies and massive black holes are challenging existing theories. Meanwhile, on the smallest scales, researchers have hit a wall. Beyond Heisenberg's uncertainty limit, subatomic particles behave in ways so unpredictable that they slip beyond our grasp. Researchers studying the large-scale structure of the universe are facing a significant dilemma. The more they investigate, the less the observed patterns align with the established theories of the Big Bang and cosmic expansion. But what does this mean? We are standing at a thrilling crossroads where groundbreaking discoveries are imminent, both in the microcosm, the macrocosm, and our universe's origins. For decades, physicists have struggled to reconcile the largest cosmic phenomena with the principles of quantum mechanics. Yet, quanta are the fundamental building blocks of everything, stars, planets, and galaxies alike. If these two fields of physics remain incompatible, it's not because something is wrong with the universe itself. Rather, it suggests that researchers have yet to pinpoint the missing links and errors in our understanding. While scientific crises often pave the way for revolutionary breakthroughs, some of the long-established figures in astrophysics may have to reconsider their positions. Will the scientific community reach a consensus? The debate is intense, as some researchers cling to long-standing theories that have never been directly proven through observation. After all, no one has ever witnessed the Big Bang or physically observed the expansion of the universe. Now, the James Webb Space Telescope is revealing new insights, and despite the evidence, some scientists resist change, adamantly defending theories that no longer hold up. This situation echoes the struggles of the past, much like Galileo, who faced persecution for asserting that the Earth orbits the Sun. Yet, there is hope. Young, open-minded scientists, including Harvard doctoral student Rohan Naidu, are embracing these new discoveries. Naidu applied his algorithm to James Webb's deep-field image and uncovered what could be some of the oldest galaxies ever detected. As soon as NASA released the data, Naidu processed it through his system, leading to an astonishing revelation. One such galaxy, Glass Z13, was calculated to be 13.6 billion years old based on traditional redshift measurements. This suggests it existed merely 200 million years after the supposed Big Bang. However, given that galaxies take hundreds of millions, if not billions, of years to form, something about this timeline doesn't add up. This discovery set off a scientific upheaval. The reliability of redshift calculations was questioned, James Webb's instruments were scrutinized, and Naidu's results faced skepticism. Yet, repeated analyses confirmed the age of the galaxy, reinforcing the need for a paradigm shift. The James Webb Space Telescope is dismantling long-standing assumptions. Renowned physicist Michio Kaku, one of the few actively working to bridge quantum physics and astrophysics, welcomed the findings with enthusiasm. He summed it up simply: James Webb is toppling the fragile house of cards that astrophysics has relied upon for decades. Many scientists had expected the telescope to validate their theories, not challenge them so dramatically. So, will the field of astrophysics adapt to these revelations? It must, because the universe itself does not lie. Currently, many of these groundbreaking findings are undergoing peer review, where experts critically assess research for potential errors. This process often sparks further innovation and refinement. Moving forward, scientific claims will likely be met with greater scrutiny before being presented as fact. The long-standing belief in a 13.8 billion-year-old Big Bang is already being questioned, and its unraveling may prove to be one of the most transformative moments in modern cosmology. Sir Roger Penrose, the renowned British astrophysicist and Nobel laureate, has cautioned that, given the current circumstances, we must return to a foundation of reliable data and observations. In essence, this implies that any theory relying on dark matter should be reconsidered, as its existence remains uncertain. If dark matter is dismissed, the entire framework of modern cosmology could collapse, necessitating a complete re-evaluation of our understanding of the universe.